Hello, welcome to the online lecture number 15 of CS531 Computer Systems and Architecture. I have already announced that this is the last class of this course. Today I'll make this video short and quickly explain 2-3 techniques about how to prevent the cover channel and side channel attack that I have explained in my last class. So if you have any doubts in these two attacking technique, then watch lecture number 14, that is the previous lecture, to understand these two the side channel as well as cover channel attack properly. So in last class I have also explained that both side channel and cover channel attack are possible by observing the access behavior of some application. So in case of side channel attack, the attacker observe the access behavior of victim application, and in case of covert channel attack, the spy application measures or observe the access behavior of Trojan application. As I have explained in my last class that the measurement method like prime probe and flash reload can be used to measure the access pattern of a victim application. So these measurements are responsible for the side channel as well as the cover channel attack. So if somehow we can prevent to measure this access pattern, then we can also prevent the side channel as well as the cover channel attacks. The full name is relaxed inclusion cache for mitigating last level cache side channel attacks. So before discussing this paper, let me quickly explain the basic concept of prime probe again today. So if you remember my last class, what I explained for prime probe, in prime probe, the first phase is called prime phase. In first phase, the attacker requests for some blocks for these two sets, set 1 and set 2. And after this prime phase, the set 1 and set 2 will be filled by the blocks of attacker. After the prime phase, the attacker will wait some time and it will observe the behavior of victim application. And in this time, if victim application request for some blocks which maps to set one, then it will convert the cache state to this condition. So after some time, when the victim application requested for some blocks which also maps to the set one, then some of the blocks which are currently residing in set one and the blocks which belongs to the attacker application will be removed, and in place of this block, the blocks from victim application will be placed like this. So now this point also I explained in my previous lecture that to maintain the inclusiveness of the cache hierarchy. So in prime phase, the attacker requests for some blocks which maps to set one and set two, and after the prime phase, the set one and set two will be filled by the blocks of attacker. So and at the end of prime phase, the attacker will wait for some activity performed by victim application. And so during this time, if victim requests for some blocks which are also residing in set one, then some of the blocks which are currently residing in set one will be removed, and in place of this, the blocks of victim application will be placed like this. And also, if we remove some blocks from last level cache, then to maintain the inclusive property of the cache hierarchy, we have to send a invalidation message from last level cache to the L1 cache here to remove this block from the L1 also. So ultimately, the blocks which we will remove from last level cache, the same blocks we have to remove from the L1 cache also to maintain the inclusive property. So this is called prime. This is the what I have explained for prime probe attack. So and then after this, the probe phase of attacker will start. I am not explaining the probe phase. The probe phase is mainly to request the same set of blocks again by the attacker and then measure the access time of both the set one and set two. Okay, so the main point here is when the victim application is requesting for some blocks and these blocks are mapping to set one, and we want to remove some old blocks from set one, the blocks which are belongs to attacker application, then the same blocks must be removed from L1 cache also to maintain the inclusive property. So these point is very important, and based on these point, the paper that we'll discuss today, that RIC is proposing a prevention mechanism. I'll not explain this paper in detail for you also. It will be enough to just understand the basic concept of this paper. I'm not expecting that you should read or you should understand the paper in detail. Just the basic understanding of this paper will be enough for this course. So just I have explained you that the measuring techniques is the for example the prime probe that the technique is mainly depend on the inclusive nature of the case hierarchy. So now here so now if we change this property of inclusiveness little bit, for example, so when the victim application is requesting for some blocks, then we have to remove some old blocks from this set and we are placing this block here. But to maintain inclusiveness, what we are doing, we are sending an invalidation request here and we are removing this block from here also, from this L1 cache. What if we if we don't do it? If we maintain this type of situation where we will remove the blocks from last level cache, that is fine, but we will not send invalidation request to L1. That means we'll allow to keep this block in L1 but not in L2. So that means this cache is no longer a complete inclusive cache. So this type of cache is called non-inclusive. That means it is not guaranteed that whatever blocks present in L1 will be also present in L2. Another important point to remember is that the blocks which are responsible for side channel as well as cover channel attacks are mainly the read-only blocks and the thread private blocks. So if you remember in my last class, I said that in case of AES encryption, there are some pre-calculated tables which are stored in cache, and the attacker tried to observe the access behavior of this table. So these tables store the read-only information. They are not stored for read-write mode. They are just read-only blocks stored. So, and these read-only blocks are responsible for the this cache side channel attack. If you go for covert channel attack, then these blocks are thread private block. That means blocks which are only belongs to a particular thread. So these point is also important for to understand the concept of the paper that I am discussing now. RIC use this concept and do not maintain inclusive property for read-only blocks as well as the thread private blocks, which I will explain in detail now. The paper says when the victim application will remove some block from here, don't remove this block from L1. So if we don't remove the blocks from L1, then the blocks will remain in L1. That means when the probe phase will start and attacker will re-request the block, then in this case there will be a hit for these blocks in L1. So it will not require to go for L2 also. So if you remember the previous case when we are removing some block from set 1, then we are removing the block or invalidating the block from L1. That's why in the proof phase when the core was requesting again, then we have to go for L2 cache. But this is not true here, because since this we have not invalidated the block from L1, so when we request them again, these blocks are still there in L1. Hence, it will be difficult for an attacker to measure the difference of time in set 1 and set 2, because in both set 1 and set 2 the attacker will find cache hit and not the cache miss, so which is a prevention of exposing the excess behavior of victim application by the attacker. The experimental section of this paper shows that if there is a L1 cache of size 12 KB and having associativity of 3 ways, then this cache is enough for L1 hit for all the critical access. That means for all the critical access, there will be a hit in L1 and it is no need to go for L2. Hence, it will be difficult for the attacker to observe the excess behavior of the victim application. So this is the basic concept of the paper RIC. I'm expecting from your side that you should read the paper once and try to understand these concepts that I have explained here. You can also watch my video again and try to understand the basic concept. If you understand the basic concept, then it is enough. I'll not ask a very low level question or very technical question from this paper. Only understanding basic concept is enough. The next paper that we will discuss is called Disruptive Prefetching, Impact on Side Channel Attack and Cache Design. So this paper is mainly depend on how we can use prefetching technique to prevent the side channel as well as cover channel attack. Or we can say that how we can use prefetching technique to prevent the measuring of excess pattern or excess behavior of some application. So to understand the importance of prefetching, let us discuss the prime probe attack again from this point. So in this point where of the prime phase of attacker is already performed, and also victim has already requested for some blocks which are present in the set 1, and it has already removed some blocks from of attacker. So now, in prime probe attack, from this stage, the next stage is probe phase. In probe phase, attacker will request the same set of blocks again, and and based on the number of hit and miss, it will count the excess behavior of victim application. This part is clear to you. But now, if before starting the probe phase, if somehow we can know that which are the blocks that attacker will request again, and if there is a efficient prefetcher which will prefetch those block before requesting by attacker and place it here in this place, then what will happen during the pro phase when attacker will request for those block, then there will be no miss here because the prefetching technique will already fetch this block and place it here. So it means that an efficient prefetch technique can prevent both side channel as well as covert channel attack if we use it, if we can use it properly. Now, the paper that I am discussing here is using the same concept. What they are saying that use an efficient prefetch technique to prefetch the block which the attacker will request during the pro phase. And the main concept of this paper is how to propose an efficient prefetch mechanism to prevent this type of attack. But it is not always true that the presence of prefetching technique will always prevent the attack. This paper proposed a technique, and based on this, or you can say this paper proposed an attack, and they claim that this attack is possible even if there is an efficient prefetching algorithm running. And you can see that the paper that I am showing now is from 2019. That means a very recent paper. So it shows that even the presence of an efficient prefetching technique, the attack is still possible. And the research of computer security or security in cache memory is going in two directions. Some people are proposing new attacks every day, and there is another group which are trying to propose some countermeasure to handle or prevent all these attacks. This is also a very recent paper, but this paper is proposing a countermeasure based on prefetching. So as I said, the research is going on in both proposing new attacks as well as proposing new countermeasures. This is another interesting area of research in memory systems and architecture, and only knowing the basic concept of memory is enough to start working in this area. So that's it from cache securities. I am not teaching anything more. But before finishing the lecture, let me quickly explain about the syllabus of EndSem exam. Everything that I have discussed after midsem are included in the syllabus. So after midsem, I have covered utilization issues, DRAM basic architecture, DRAM refresh, row hammer technique, non-volatile memories, hybrid memories, and the basics of cache securities. Everything is important for EndSem. So follow all the lectures, read all the study material that I have already shared with you. All the best for your exam. And here I have just discussed the syllabus, the evaluation plan, and all for this. I'll send a separate mail. Most probably, I'll send the mail by Sunday. I hope from this course you have understood the basics of memory architecture, and now you can continue your research in this area. The important concept that I have covered in this course are modern multi-core architecture, that is CMPs, TCMPs, last level architecture of CMPs, that is SNUCA, DNUCA, replacement policies, cache partitioning, utilization issues, different memory technologies like SRAM, DRAM, and NVM technologies, advancement in DRAM as well as in non-volatile memories. I also explain what is hybrid memories, what are the recent advancement going on in hybrid memories, memory securities, and some other advanced concept of cache architecture. I hope that the knowledge you have gained from this course will help you in your future research. So here I am officially finishing my last lecture for this course. But before leaving, I just want to inform you that if you are doing a good term paper, then don't just let it go. Try to finish this work, and we will try to publish it in a good conference or in a journal. So any help required from my side, I'm always ready to help you. Okay, see you all in the campus soon. I am hoping that the final year student will at least come once to the campus. So I hope I will meet you at least once. Take care. Bye.